some variety as well. Now, Arduino is another kind of platform. It's gotten popular in the last couple of years. Actually, they've been around for at least 10 years, I think. And they actually came out of people who want to do what they call robotic art or digital art. So there are people who in art school that do not just static sculpture, like you carve a person or carve something, but they build robots. And these robots, what do they do? Do what the artwork is supposed to do. Just leave you with an interesting impression of things. So instead of something that sits there not doing anything, the robotic art would then interact with you, for example. So you walk over to them, take a look, and then they tilt their head with you. And then you step back, they come forward, and you say, hey, no, I step forward, and then they step back. So kind of funny little robots that don't do anything. I'd rather have one that cleans my house, but this one, these ones just are more for amusement to me. So people use Arduino to build that kind of robots. Why? Because these, for one, they just have to write the software. They can just get the hardware boards, and also it's open source, both hardware and software. Well, I should say hardware part is really the board design, the schematic, the layout. That way, you know which signal is what. But of course, the components themselves are not open source, right? The microprocessor, microcontroller, these other components, you can't look inside. But anyway, so they use the Atmel family of microcontrollers. So ATmega 168, that's one kind of similar to what you saw on the very first platform, right? Remember the AVR butterfly, that name tag one? So that's kind of the similar family. But you notice that the chip is much bigger here. That's because this is in the different package, a DIP dual inline package. So that's the older package of things. But no, they upgraded this, and so now they have a newer version. And also the software side, you program in the C-like language, and it's more of a stylized C. So you have to have certain functions to work in their environment. And if you write it that way, then you can use a lot of their library code. So a lot of courses on embedded systems use Arduino as their platform of choice, and some labs use this too. And really a good reason for using Arduino is if you want to try different combinations of controller and peripherals. There are these peripherals on these circuit boards called Arduino Shield. So that's a way to just plug in an expansion module on top. So it has these two rows of pins on the side, you see, right? Those posts, they'll go in, and they are stackable because the male pins go down, female connectors on top, right? So you can stack these. And so now, Arduino is one organization that, they own the name Arduino. But there are plenty of other third-party companies making what they call Arduino compatible. But officially, there are only a couple of these shields. Most are made by third party. I think hundreds of these. But not all of them are compatible with each other, so you have to be careful. I think there are 2 or 3 different standards, so you have to know version which one. Otherwise, you plug in and it blows up. So be careful. So this has gotten pretty popular, and even Intel jumped in recently with their Pentium-based design. They make a 32-bit Arduino board that way. Because Intel is a funny company. They got a good ride with Microsoft Windows for a long, long time. They say, haha, the low end, we don't care. And then out of nowhere, ARM came out with all the smartphone tablets, and oh no, we're missing out on. And so they're kind of worried, and so they're jumping ahead and thinking, okay, we got to catch the next one. So little embedded systems. So then how do they get in? Well, they put their Pentium or one of their old chips onto a into a new package with lots of embedded features, and then throw it and then make it an Arduino compatible board. So that's Intel's effort in this. And we could have gotten some, but the problem is our TAs are not trained enough to help you with that. So that's why we didn't decide to go with that Intel board. But maybe another time. Okay, now here's another one that is. I just want to show variety. Okay, so so far you've seen a lot of these kind of lower end ones. This one is more medium to higher end. This one's from TI, and TI also makes a few of the ARM compatible or ARM microcontrollers. And this one actually is a dual core. And so it's a dual core ARM with on-chip flash and RAM. So 160 KB of RAM. You think, that's not very much, but for something that's plenty. And it's dual core that runs in lockstep. So why would you want to use one that draws twice as much power, does half the thing, right? So why would you want to do that? Well, this was in certain applications. There's good reasons for doing that. For redundancy, for fault tolerance. Maybe sometimes you put this in outer space on a satellite. Well, maybe not this one, but something like it. And there, when you send something out in the space, what do you get? Alpha particles, gamma ray, all that. And so you get bit errors very easily. So even if you have strong shielding, a few of these would still escape and then hit and then turn a bit from 0 to 1, 1 to 0, and then it's wrong. And so that's why doing dual core like this in lockstep, that's actually a good thing, because then you can check. If one of them has a problem, you could actually roll back and say, hey, these two are giving me different answers. They should be identical. Right? So that's one. And this one supports floating point as well. So sometimes that's easy. Many of those previous ones don't support floating point. Okay. And then this has the simulator, assembler, all that.